Hello, this is Mr. Humward here. For this assignment, this is the 5.2 free body diagram assignment. It is very important to understand this assignment to do well on the Chapter 5 test. So, 5.2 free body diagram assignment practice. So to start, net force is the sum of all the forces added together. So F net is the same as the sum of all the forces. That's that sigma symbol. It means adding all the forces, or sum. Or F1 plus F2 plus F3, however many F's you have, added up together. That is the net force value. All right. So for number 2, and for this assignment in general, I'm going to make this simple. I'm going to say that gravity for this assignment is 10 meters over seconds squared instead of 9.81, just to make my calculations simple, because I don't want to use a calculator. So as I'm doing this, I draw a little diagram, draw a little box if I want, and in the middle, put my dot, and 15 kg box means I have a mass of 15 kilograms. I know to find the weight going down, I have to multiply mass times the acceleration due to gravity. And that's going to be 15 times 10 here. I'll get 150 newtons. And I'm going to choose this to be negative going down. So in general, my sign convention will be, for this assignment, positive going up, positive going to the right, negative going down, negative going to the left. All right. So now I know that there's a negative 150 newtons going downward. If the box is on the ground, the net force going up, the net force has to be 0. So the force going up, the normal force, this has to be 150 as well. Because it has the same value as the bottom one, but the sign will be switched because it's pointing upward. Alright, so now we have a net force of 20 newtons acting on it, and a applied force of 45. If I know an applied force of 25 newtons is acting on it, and my net force is 20, I can add that together, as net force is the sum of all forces. 20 equals 45 plus some value, which I don't know. Call it x. So my force to the left is just going to be negative 45 to both sides. So x equals negative 25 newtons. So that's going to be my force to the left. Negative 25 newtons. And there's my diagram. Now I can do the second one. For B, we have this 45 newton box moving across the table at some constant velocity. So again, we have a 45 newton box going down. That's our weight. Say it's negative 45. And then a normal force going up. And that will cancel out. And this has a constant velocity. So that means, and this is a key thing for this assignment and for this chapter, if you have a constant velocity, that implies that for your acceleration value, which is the change in velocity over change in time, that your velocity values are the same, v initial equals v final. So then a is 0. Because v final equals v initial, well, we have no change, so we have no acceleration by definition and from the equation. So if I know we have no acceleration, I know the force, the net force, equals mass times acceleration. And if a is 0, then that net force is 0. So if I have a constant velocity, that tells me the net force is 0. So 30 newtons to the right, and then negative 30 will be to the left. Because this has to cancel out, my net has to be 0 in the horizontal direction. Constant velocity. Alright, for this problem, it's an 80 kilogram skydiver, that's a mass. So weight equals mass times acceleration due to gravity. We'll say that's going to be 80 times 10. So 800 newtons. And I'll draw a little diagram or a little person. And he has a parachute. So with this skydiver, he has some force going up and some force going down. Well, I guess he wouldn't have a parachute out because he's falling. He has a net force downward. So I'll erase the parachute. So the downward force is going to be negative 800 newtons. He's going straight toward the down. The net force will be 600 newtons. He's still falling, so that's going to be positive, or negative, I mean. So negative 600 net. So he has a little bit of force going up from air resistance. That's going to be negative 800 plus x. So we add 800 to both sides. And we're going to get x equals our value, 200 newtons, going up. All right. For part D, here's the mass again, 40 kilograms. Weight equals mass times gravity, so 400 newtons. That's going down. Sliding down a little pole at the playground. Our mass is going downward, negative 400. And our force of friction is going to oppose that. So going upward, 340. Our net force, we add those together. So 340 minus 400. Or technically when we're adding, we just say plus negative 400, but it doesn't matter much. So value negative 60 newtons. And that's our net force. So for example, for E, we have this box sitting on the floor. It's not doing anything. And this is 50 kilograms again, 50 times 10. Weight equals mass times gravity, 500. So that's going down. Then we have one going up. So 500 going up, negative 500 going down. Our net force is going to be 0, of course, because if we add those together, It's sitting on the floor. It's not going anywhere. F net equals 0. And we have no horizontal component either. It's only vertical, up and down. Horizontal, vertical. For number 3, I have this mass, this 5 kilogram cart. He sits on this track and experiences this force to the right, 2 Newton force to the left. I need to find this net force, so 5 times 10 is 50. Going down, and 50 Newton going up. So this little cart is a force going down, force going up. He has this force to the right of 5 newtons and one to the left of 2 newtons. I'll put that negative sign there. We want the net force, the one in the y direction, the F net y will be 0, of course. It's not going up and down. The one in the x direction will not be. It will be 5 minus 2, or 5 plus negative 2. 3 newtons. For number 4, this little skydiver has a force 630 newtons downward, 230 newtons upward. So downward, (630 newtons), upward 230 newtons. So if I add those together, I should get negative 400 newtons. I would assume the skydiver accelerating downward due to the negative sign on the force. And if the acceleration is moving downward, the velocity is moving downward as a equals change in velocity over time. And these are both vectors. So they both have the same direction usually. And that's why. So they're vectors. Alright, for this problem, it's a little different. For number 5, we have a force 750 newtons downward and 850 newtons upward. So with this problem, the skydiver has this force going up as we have a positive net force, which means that's going up of 100 newtons. If we have a positive net force, we have a positive acceleration, as these are similar vectors. Because mass is not a vector, it's scalar. So positive force, positive acceleration, because force is directly related to acceleration. So the skydiver is accelerating upward. However, the skydiver would be moving downward. Or could be moving downward. I would assume he would be still. He could have just had a brief updraft of air, but he could still be falling down. Alright. So for number 6, we'll draw this another couple of diagrams. If it's a 15 Newton object, that means that it has a weight of 15 newtons going down and a 15 Newton normal force going up. And if it is a 10 Newton force going to the right and it is not moving, then it must have an equal and opposite force in the other direction of friction, most likely. It has to be negative 10. So our net forces are going to balance out. So 10 plus negative 10, or 15 minus 15, or plus negative 15, and we should get 0 for both the x and the y. Alright, if this is a 20 Newton box, and it's pushed to the right 15, or we'll assume it's the right, and it has a constant velocity. That's that definition again. Constant velocity implies, so constant v implies no acceleration or force, net force. As a equals 0, and if a equals 0, then that also equals f net. So if we have a 15 Newton going that way, we have to have negative 15 going that way to make that true. Then this is true. So another one where it's sitting on the table, going up, going down, negative 30, and 30. Alright, so the last one, we have this 97 kilogram firefighter. He's sliding down a pole. Multiply by the acceleration due to gravity, because I want the weight. Just mass times acceleration due to gravity. And I will get, since he's sliding down the pole, a downward force of 970 newtons, unless it's negative, and an upward force of 650. And my net force, if I add that together, it's going to be 320. And it's negative, going down. And that is the video.